Hey guys, so I wanted to chat a little bit more with you about literal equations tonight. We saw some of these in Literal Equations 1, which is a video we did while we were away from school for Irma, and I want to look at some other literal equations now because there are definitely a lot of questions about these. I know we talked some about this in class today, but given that there are a number of people that were absent, I wanted to be able to post a video here to go over what we looked at. So let's take a look at a literal equation here. I'm going to look at the equation y equals 2x plus q. And what makes this a literal equation is that it has multiple variables in it. We have a y, an x, and a q. And I'm going to ask us to solve this literal equation for x. Solve for x. So the first thing I would like us to do is identify where that variable is in our equation. So here's our x. I'm going to circle it. And remember in class we talked a little bit about the onion method. And we talked about the onion method is not an actual thing in math, but it's a nice little way to remind us what to do when trying to solve for a variable. And we said in the onion method we were going to circle the thing that was stuck to the variable and then circle the thing that was further from the variable. And we're going to peel one layer away at a time. So if I want to peel that outside layer away, how am I going to get rid of that plus q? How do we peel that outside layer away? Well, we get rid of a plus q with a minus q. And that'll leave us with y minus q. And we can't really do anything with y minus q because they're not like terms. So we've got y minus q equals, and the only thing left over here now is 2x. And let's think about our onion again. We've got to peel that 2 away from the x. We want the x by itself. So we're going to peel that 2 away. Well, what's happening between the 2 and the x? Yeah, multiplication's happening between the 2 and the x. So we're going to peel that 2 away with division. 2 divided by 2 is 1. So we're going to say x equals y minus q over 2. And that's it. That's now been solved for x. We've rewritten that equation in terms of what x is equal to. Cool. So let's look at another example. And I want you guys to try this one out. It's very similar to the one we just did. See what you come up with. If I have a equals 4b plus c, and I ask you to solve for b, can we do that? Let's give it a try. Cool, so let's go ahead and see what we should have done. Hopefully you guys got it right. If not, we can take some notes right here. I'm going to get rid of first, well, let's see. I'm going to circle my b because that's what I'm looking for. The 4 is stuck to that, and the plus c is stuck to that. So first thing I've got to get rid of is the outside layer, and the furthest away layer is that plus c. I'll get rid of that with a minus c. And I've got a minus c equals 4b. And then I have a 4 and a b. That's multiplication. And the way I get rid of multiplication is I divide by 4 on both sides. And I end up with b equals a minus c over 4. Cool. Let's take a look at another kind of question here. So let's take a look at this fun question. Area is equal to base 1 plus base 2 divided by 2 times height. Anyone recognize that formula? That's the formula for the area of a trapezoid. The area of a trapezoid. So let's say that I ask us to solve this equation for, I want us to solve for b2. I want us to get base 2 all by itself. So here we go. We've got base 2. And the closest thing to base 2 is that base 1. And the closest thing to both of those is the 2. And the final thing we can get rid of is the h. So we've developed this onion here. It's got a lot of layers. It's got this outside layer with h on it. It's got a further in layer with a 2. It's got a base 1, a base 2. There's all these layers. And we're going to peel one layer off at a time. So first we're going to peel off this h layer right here. And that right now says times h. And the way we get rid of times h is divide by h on both sides. And that's going to give us a over h equals base 1 plus base 2 over 2. And the next layer that we want to peel off is we want to peel off the divide by 2 layer, this layer right there. How do we peel off the divide by 2? Well, we're going to get rid of the divide by 2 with a times 2. So we'll multiply by 2 on both sides. And that's going to give me 2a over h equals, the 2's have canceled, and I've got base 1 plus base 2. And finally, if I want to get base 2 all by itself, I have to get rid of that base 1 right there. It's a positive b1, and I get rid of a positive b1 by subtracting b1. And I'll end up with base 2 is equal to 2 times the area divided by height minus base 1. Okay? Now I'm going to give you one like this, or close to this, for you to give a try. Try this out. Q equals x plus y over z, and I want you to solve for y. Give it a try. All right, so let's take a look. First thing we're going to do is identify the variable we're looking for, y. The next closest thing to that y is that plus x, and then finally the z. We're kind of identifying the opposite of our PEMDAS here. That plus x is right next to the y, and then we've got to divide by z, my apologies. So first thing we're going to do is get rid of divide by z, and we will get rid of divide by z with a times z on the left and the right. Anything we do on the left has to happen on the right. That's going to give me qz equals x plus y. And now I'm still trying to get that y all by itself. So how do I get rid of a positive x? I get rid of a positive x with a negative x. And I get y equals qz minus x. And that's my answer. It's not really too hard. What we're really doing here is exactly the same thing we did when we were solving equations that had numbers in them. Our only difference this time is because we have all these different variables, we're not really able to simplify. So we're still going to continue to follow the steps we would follow if this was a regular equation, and we're going to do opposite or inverse operations to kind of peel these onion layers away. I'm going to give you one more question I'd like you to try. So give this a try real quick. Let's try 4x plus by equals w. And I want you to solve for b. Give that a try. Cool, so let's identify really quickly what we were looking for. We want this b all by itself. It's stuck to a y, which is stuck to a 4x. So we got to get rid of that 4x first. We'll do that with a minus 4x. That's how I get rid of a positive 4x as a negative 4x. I've got by equals w minus 4x. And then, in order to get b by itself, if I want b all by itself, and this is actually a place where some people make a mistake. If I want b by itself, I don't want to divide by b. If I divide by b, b is going to move over here somewhere, and I don't want b over there. I really, really want b to be by itself. And the way we're going to do that is we're going to divide here by y. Now y is going to cancel with y, and we're going to get b equals w minus 4x over y. So hopefully you guys were already kind of understanding this in class today, and this is just a nice little reminder, a couple practice questions for you. If not, tomorrow is Tuesday, and Tuesday mornings means tutoring, so you're welcome to come on in for tutoring in the morning. And if you're keeping up with us from afar because you're still out of town, do your best to take some notes on this, and when you get back, we'll do our best to get you caught up. All right? I hope you guys have a good night, and I'll see y'all tomorrow.